it solves the problem and says this is lower than 6.8. It is class A. Again, two types of classifiers, support vector machine and k-nearest neighbor. These classifiers work on a similar principle, but they are infinitely more complex than my simple the mean of mean values. Support vector machine does the following. It plots the data in a, let's say this is the two-dimensional space. It plots them in group A and group B. It creates these vectors depending on the elements that are closest to each other, and then creates a, based on these two vectors, which are support vectors, creates a hyperplane that separates the area A from area B. And you can imagine from here on end, we just plot, the features are plotted against this hyperplane, and if they're in the area A or B, they're classified as class A or B. The thing with the SVM is that if it can't solve, for example, the task in two-dimensional space, it projects it to a higher dimension, so in a three-dimensional space, and tries to separate them again, then to four-dimensional, fifth-dimensional, and because it's an algorithm, it can do that. Although after the third dimension, we cannot imagine what is the next projection. And another example, k-nearest neighbors, a very simple yet very effective algorithm that plots a given data or feature and decides its class belonging, in this case, blue square or red triangle, depending on its nearest neighbors. So if I use 3 nearest neighbors, it says 2 red triangles, 1 blue square. So this should be a red triangle, and this is class red triangle. But if I use 5 nearest neighbors, it says, so the nearest components to this, or nearest elements, are 2 red triangles and 3 blue squares. So this is class blue square. And again, I am just illustrating these two examples, but this is the reason why it is good to know how each classifier behaves, what it does, if not mathematically, at least in principle. So we know what our data should be and how our data should be conditioned. For example, in some cases, we need to normalize the data to a given range or standardize the data. So the classification the problem might not be in the feature, but that we have not conditioned the values properly before we provide them to our classifier. I will mention a couple of software. So there is, for example, MATLAB's machine learning toolbox. It is very, how should I say, very friendly, very easy to use. And most of the machine learning software are like that. So you just prepare the data and select your algorithm and press train, and you can select couple algorithms, press train, and see what happens. This is, as I said, MATLAB, machine learning toolbox to be more precise. Weka, which is, I will show it in the end of the lecture. It is a machine learning toolbox. It is entirely freely available. and also Rapid Miner, which is again a machine learning toolbox. And in the lecture next Friday, there are examples and demonstrations of two of these systems.
This toolbox,
So
MATLAB, you said it say will work with MATLAB. Is R has a
yes,
toolbox and Python?
in all cases, uh, excuse me, I didn't hear the last part of
I mean,
your question. So
Python and R's, I think they have also toolkits.
yes, so about the classification, so you need, for example, in Weka, you need to provide the data and the features once you have uh, calculated them. So maybe you will need some different product, software product, to extract the data or a program. But once you have them in the format that I have shown as feature vectors with feature in the end, then you can load them and classify them uh, in the toolboxes. Yes.
Hmm.
So
Or people can write the script from scratch.
yeah,
Or
you can
this is
do that.
difficult. Okay.
Yeah, as long as I said, as long as you can find a way to transform the image or the selected features, as long as you can produce numeric values that can be structured in a given way and provide them to the classifier or load them in the toolbox, for example, in Weka, yes, you can do that. But even if you write an entire program from scratch or use some software that both extracts and classifies data. For example, MATLAB is good at that. So you can write a program that processes your images, extract the features, and once you have the features, then you can classify them in MATLAB, in the machine learning toolbox. So we have created our model, and now we might need to tune it a bit before it is ready. As I said, these algorithms, they often have some parameters that we set as default arguments. And in some cases, with some parameters, the algorithm behaves better and produces better results than with other parameters. And these parameters that affect the way the model is created are called hyperparameters. So one approach for optimization of these parameters is through a grid search. So for example, we have parameter A and parameter B, and we test our classifier and we create models with this parameter varying in the ranges from 1 to 10, parameter A, and parameter B from 5, to, again, some range. In this case, from 5 to 9 would have been this. These two lines are redundant, but I have done them not, again, as a simulation, not as exact parameters, but as simulations of a parameter. And from there on, we test our system with 1 and 5, with 1 and 7, with 1 and 9, parameter A and B, and we get some results. And after we cover all of the combinations, we can check which combination gives us best results, and we select this combination for the creation of the final model and as I said, the final implementation of the algorithm for whatever uses we have for it. Now,
I have a
yes,
question. I have a question regarding
yes.
this slide. What is the importance of this hyperparameter?
So,
Why
uh,
we need this?
I can give you an example
Mm,
with a hyperparameter for the support vector machine. You can one of the, and as I said, they're formulas,
mm.
and the hyperparameters are part of the formula. So, and you just set,
A constant in the formula.
yeah, so you set a certain value, and these values that we have set can and often do affect the classification. For example, one such hyperparameter here is a box constraint,
Mm,
and you provide it as a value, as a percentage, and the box constraint is the allowed error. So the SVM roughly tries to uh, generate lines between the closest elements from the two groups. But you can imagine sometimes they are mixed there, and it's not that easy. So we set a level of error tolerance. For example, what degree of uh, error or overstep in this area we can allow. And you can imagine if we're very strict and very loose with what we allow with our error tolerance, the results are different. So for our case, we find the best error tolerance for this algorithm, and we use it when we train the classifier. So, and there is a question: how can the geologist
mm.
simulations by AI and machine learning? Um,
I can answer
so,
this question later,
uh,
Virgin, if you would like.
okay.
Yeah.
So then I will continue. And now, a couple of moments about verification and classification. And so we need to verify that our classifier is working correctly,
Mm-hmm.
and we need to test it also. And it is usually good to be to not be very how should I say, tolerant or very careful with our testing, but instead we should really try to find the limits of our classifier and see if it in a real environment can it do well. So it is good to have a type broad testing data and um, test it as extensively as we can. Now, here I have a callback to two different slides side by side. And this is the feature selection slides where I first gave you an example of an algorithm that was classifying cats and dogs.
Mm-hmm.
And what I did was I tell you, I select these features, then I told you, and now I test my classifier, and yes, it is working. And later I proved that it wasn't working.
Mm,
But my proof of concept idea, and you can see, includes testing with data that I have used during the creation of the algorithm. This is not something that you should do or something that should happen. The algorithms should not be tested, or your classifier, your model should not be tested with the data it was trained on,
mm-hmm.
because that, as you can imagine, it will
Give a good result.
prove that it is, yeah, because that is what it was trained on.
Mm.
So this is an example of a error, and a very serious one, because as I have proven in the next slide, uh,
The
it
result is
wasn't a
okay.
very good
Yeah.
it wasn't a very good algorithm. And if I had a broad range of testing data, I would have found out that finding a floppy-eared cat, not that easy. Cats usually have pointy ears. Finding dog breeds with pointy ears, very easy. Not half, but a lot of dog breeds do have pointy ears. I just trained the data. I didn't test it, trained my classifier. I didn't test it properly. I tested it with data that it was trained on. Of course, that it will uh, perform poorly. Another moment. This is another example with our data and our model creation. Here you see I don't have only dogs and cats, but bears, foxes, cows, horses. All of these animals are mammals. And now I want to create a classifier that classifies and finds out from a picture if the animal is a mammal or not. So I have mammals, I have fishes, and then I have a whale. What do I do with the whale? The whale is a mammal, but if you look at my
Fish.
data,
It's fish.
it doesn't look like a mammal at all. Excuse me?
Mhm. It's go in the category fish.
Yes, it is a mammal,
Yeah, it's
but this
mammal.
is
Yeah,
very, very close
to fish.
to being to fishes.
Yeah,
Same goes with the dolphin.
yeah, that's
That is an
correct.
outlier. That is and the killer whales as well, and we can go on, but all of them mammals, but firmly similar to fishes, more close to them. That is the so-called outlier. That is the outliers are data that belong to category A, but are in the way that they behave and they manifest are very close, if not showing properties of another
Uh,
category.
and how you
And
can solve this problem?
well, this is a very, very good question.
Mm.
Do you remember the I don't know exactly what to do with the 6.5? But 6.5 still it can be 6. In
Yes,
some cases, it can be A. In some cases, we have an outlier can be 8 or 8.5 and be a class A. It and this is again, I don't have a clear answer to that.
mm,
If we are classifying mammals from images, we
mm,
just need to find the correct features that can distinguish them. One thing that people do is sometimes they just discard them. I don't believe in this approach. Also, it is very widely practiced.
of course.
If you have 100 data samples and you just throw 5 of them away because you say, yeah, that's technically mammal. As I said, dolphin, uh,
As well.
that's dolphin, whale, killer whale, orca. Technically a mammal, but it will be very hard to put it in this here class and still make a functioning or properly functioning algorithm, or the algorithm that you have selected to function properly. So people just throw them away, and suddenly the classification task becomes very easy, and the classifier performs at 97, 98, 99%. Um, Again, it is up to the approach that you have selected. What do we do with classifier with outliers? We just need to find a way around them. Another or find just a better result that integrates them into our not better result, better feature that integrates them in our model, and try as much as we can to improve our models. On the topic of data grouping, and I just want to give this as I'm talking about testing in general, as I said, pitfalls or things to be aware of. An example, a task. We have a total of 25 elements, of which 10 belong to class A, red, and 15 to class blue. The ratio is 2 to 3. But I put forward this task. Combine the elements together so that 5 units or 5 elements create a single group. The class of each group is determined by the majority elements included in the given group. And what is the ratio of the group classes? And maybe it is confusing, but I will show you just now what I mean. First case, I grouped them vertically. 1, 2, 3, 4, 5 reds. So this entire group is a red
100%,
class.
yeah.
So this is red class, blue class, blue class, blue class, and I get 2 red classes, 3 blue classes, and my result is red and 2 blue, 3. Have I kept the correct ratio? Yes, it is reflected in my grouping.
Yes.
I group them horizontally. 2 red, 3 blue, majority of blue classes, this goes as class blue. And if I do this horizontally, the result is I don't have red.
Yeah.
Red does not exist. Or I can go in this direction. Red, red, blue, blue. This is red. Red, 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 blue, blue. This is red. 4 red, 1 blue. This is red. And 2 majority blues. But here I get my results. Ratio red to blue, 3 to 2. This simple task is shows you how we can bend reality or real ratios by clever grouping. This is why a manual grouping of data should be avoided. For example, what I mean is manually selecting which data samples we use as training data, which data samples we use as testing data. We might do that and we might have the purest of intentions, but we can not intentionally affect our results. The other thing is that in some cases, if somebody does that, then we always assume the people have best intentions, but there might be some other reason for a specific grouping. So they might try to avoid in some way, or in some way tailor the results. Again, maybe it is not intentional, but and maybe even in the case, again, it is not intentional, and the people who do that, or the person who has done that, affects the accuracy of his own classifier.
Of course.
So he affects himself negatively.
Mm.
But it is an approach that, let's say, it should be avoided. And instead, what is practiced is taking random samples. So maybe we can repeat 5, 10, 15, 20 iterations of just taking random samples. And after these 20 iterations, the random cell, a correct ratio of both groups will be achieved, and it will be reflected in our classifier. This is called cross-validation.
Mm.
So you take your entire data set, you randomize the data you train it with and the data you tested on. The groups are different, and you do that 10, 15, 20 times, and the result is
Same.
averaged based on the performance for different random groupings. And almost at the end now, we go back to the standard task. We need data, we need to pre-process it and prepare it. We need our feature extraction. Then we select the features or rank them. And then we go to classification. I said these steps, 4 are mandatory, 1 is optional. But there are options and approaches in which 3 are optional. We only need data and we need classification. And this is also used in the unsupervised approach that we were talking about. But you can imagine if I have only one mandatory step, having data, I do need a lot of data. And if I go to my cats and dogs example, this is Google. I have written cat, press enter, show images. Dog, press enter, show images. Now, if I had the capability of taking all the images that appear once I write cat or dog and just feed them in this giant classifier, and I have, again, an enormous amounts of data, it will learn and it will start classifying cats and dogs without the other steps. Again, if we have set up our deep neural network correctly. And what are deep neural networks? They are neural networks that have many layers, hence deep. And what are neural networks? The idea of the neural network is to imitate the way a brain works through neurons. So one unit or element in one layer can affect 2 or 3 units in the next one, which affects a number in the next layer, and so on and so on and so on. And what we get as a result is that this layer, or this might be a pixel, can affect 2 or 3 pixels that affect the another pixels around them. And it, on the lowest level, it can find, for example, the relation. If I go very, very, this is good enough. It can find the relation between the pixels that form the cat's nose and its mouth. So in the beginning, it will learn to discriminate noses. Then this part of the then cat's eyes, then this part of the snout, if it's a correct term for the cat, and then the ears in relation, and then it will start to learn what is a cat's head deeper on in the layers. So pixels grow into lines, grow into shapes, grow into objects, and objects within the objects that combine objects. And slowly, having seen many different images of cats, the deep neural network will learn by itself what a cat is. And this goes again for the unsupervised learning. It will learn what is a cat and what is not a cat. And once it sees an image of a cat, it will tell you this is a cat. And we haven't put, during the training, we haven't put a single label what a cat or a dog is, but it has seen billions of cats. And yeah, it can tell you that this image goes in the left hand group and not the right hand group. So this is the power of neural networks. And they are used and as again in Google, and they're researched there by their artificial intelligence R&D team. So they show very impressive results. For example, I've seen examples with a picture of a train station, and the train is just 20% of the picture is coming toward the train station, but the classifier knows this is a picture of a train or a picture that includes a train. So if you ever open Google Photos and if you have it, and you, for example, write down car, it will go through all of your pictures and find the ones where where there is a car. Even if it's in the background, it will find it. So that's the strength of these approaches, but they require a lot of data, really a lot of data. And in the beginning, I started with Goya. I will end with Rembrandt, with two examples of artificial intelligence and its powers, let's say. These are seven paintings, but only 6 are painted by Rembrandt. One is a painting created by an algorithm that was
understand how he's thinking.
Yeah, all Rembrandt's paintings were very, very detailedly analyzed. And here you can see on the next, I have provided the link. You can check it out how exactly they did it. They calculated ratios of the faces, the shades, the sharpness, the contrast, everything. And they had, again, features for all calculated for all of Rembrandt's paintings. And then based on these features, they generated a new painting. And they connected it to a 3D printer that was layering very, very thin microns layers of paint, and it painted a new Rembrandt image. And now the new Rembrandt image, it was a initiative by a Dutch bank, and it is there, and it is impressive. And I always ask the question when I give this example to the students, I ask the question, which is the fake painting? Which is the new one? The answer is this one.
I was about to say the one bottom to right.
Bottom, this one?
No, to right, the right one is this one, yes.
Yeah, I personally, I couldn't have guessed once I saw it. And usually students do not guess. Sometimes they guess it because there is a chance.
So maybe we can ask any one of the audience can guess
This
which is the
picture,
fake. Which one?
this one, the middle.
This is the fake one.
Yes, yes.
Okay.
On the upper row, the one in the middle. And he
Okay.
said, this one is fake. And I asked him, why? And he said, it is too clean. And I couldn't define what clean means and what he meant. But the moment he said it is too clean, I kind of understood what he meant by too clean. And to this day, when I look at it, it pops out. So when somebody tells it to you and says, yeah, that's too clean. It's too polished. The brain is just very, very good. It's actually an organ that all it does is to classify and learn relations of things. So it is, once you know, yeah, you can see this cleanliness, this the sharpness of the image, but still mind-bogglingly impressive result. I cannot say anything else, but mind this is an example that I have been given from 4 or 5 years. So this is an old example. A one that is very new, and this shows not only the capabilities, but questions that arise with artificial intelligence. This is a painting of this person, Jason Allen, and it was presented in a Colorado State Festival. This is from this year. If you Google the painting, it will, if you search for it on the internet, it will pop up. This happened the end of August, the beginning of September this year. State Fair in Colorado, as I mentioned, and they had this. They had, for, how should I say, not races, but events where authors present their work, either sculpture or painting, digital painting also, and they're scored, and a jury decides which one is the best, and they're rewarded. So they had a contest, was the word that I couldn't remember. And this was the winner of the contest, which turned out to be a digital image created using a text to they created using a program that then generates images based on text. DALL-E 2, Midjourney, and Stable Diffusion, just examples of such software. The author described by text what he wanted as an image, had a registration. The algorithm generated the digital art. He presented it. The jury looked at it and said, yes, this is the best art that we have seen on this county fair. This is the winner. The people who actually drew paintings and digital art were furious, as you can imagine. The author of this piece said, no, I read the the requirements for entering the contest. I have not broken any of them. And this is a legitimate creation that covers your requirements. And that's that. So AI has very impressive capabilities in the modern age, and it is used virtually everywhere. It can be as simple as you saw, distinguishing if values belong to group A or B. We have very sophisticated artificial intelligence hidden right in our pockets. And I do mention the voice recognition software that allows us to search in the internet just by speaking, just by saying what we want searched. The algorithm that can detect and distinguish voice to the voice to text algorithms are based on artificial intelligence. They need to detect and classify letters and words. They are impressive on their own. And you see the state of the art is even more and more impressive and getting better day by day. And with this, I will conclude. And before I finish, I just want to maybe to show you just exactly what I mean. This is Midjourney showcase, and you can access the link here. And these are showcase images. And for example, this is generated by the author saying this, he wants a ukiyo-e style painting of seasons changing. Or here we have a stunning vector art landscape, minimalist, red and white. And if you go to the FAQ, there was a very, very nice example. Once you type an abstract field of flowers, the algorithm generates an abstract field of flowers, and you choose one of the images. So again, I was very impressed by this. So decided to share it as an example. Once again, thank you for your attention and your time. And if you have any questions, I will be happy to answer them.
Thanks a lot, Vargan, for this very interesting talk. I think we have question from Aya in the chat, but before we answer this, I would like to open the floor for other.
Yes.
Anyone would like to ask questions to Vargan about artificial intelligence? This very nice introduction. If not, I have a question myself before we answer a question. How we can use artificial intelligence? I know that you are working with this field with biodiversity, monitoring the biodiversity.
Biodiversity.
Yes.
Yes. Oh, well, there are again many ways. For example, we can just by heart, if I have to give answer, two ways come to mind. First of all, the first approach is for analyzing data. If we have
existing data.
Excuse me?
Existing data.
Yeah, if you have just data of changes of animal populations, of habitats, and so on, and how changes of habitats or affect the animal population, animal migration, patterns of behavior. If we already have this as data, we can create tools to analyze, to find relations, to predict future, trends, and of course, help us to avoid them. Another one is by creating direct applications. So what I mean is creating systems that, for example, analyze real life data and help us, for example, estimate the levels of pollution, estimate levels of deforestation, estimate the quality of the air, and so on. And we can have systems that we can, for example, plant in areas, first collect data, and then using these systems analyze the collected data. For example, if we can create, just again, quick example, maybe this even exists. We create an algorithm that can detect, I was always showing pictures of cats and dogs, but maybe a wild animal, maybe foxes or other wolves, bears, and we can install cameras in the forest and monitor the activity in the forest for a given time period and remotely collect data for the activity or of these animals, or how often they are observed in this forest, and we can make estimations about their population there. So either we can make a system that is autonomous and can monitor a very long time, for example, an area in some far location, let's say forest, field, and each time it detects a given animal, fox or bear or wolf, it can just with the camera detect it and then inform us about this detection, so we know that this animal is currently there, even in real life, or even if it's just in a recording, if the camera has recorded for months at a single place, and we can use an automated algorithm just to find in these recordings places where this animal appears, and that will help us at least with the annotation of the data, for example.
Yep.
And there are many other different such ways, not only to analyze data, but also to create applications or systems that are installed in the field. Yeah.
I have another question. Sorry, Vargan, for that,
Yes, of
because
course. Yes.
discussion is just to bring things. Can we use artificial intelligence to build future scenarios related to economic activities?
Yes.
I mean, for example, now, for example, this country, Bulgaria, for example, you are in Varna. I think your economy is based on a Varna Lake and the port, correct?
Yes.
And then you have like some numbers, like for the last 10 years, the income of the Varna, some numbers related to economy. And then we start to say, okay, what if in the future added another element to the economy? Is
Yes.
this will be positive, negative? So do you think artificial intelligence can be used for something like this?
Yes. It can, and actually these type of tasks are called usually regression tasks. So in them, data is used, but not as a not it is used as an example of it is used to analyze behavior up to a given point, and then based on that behavior, the algorithm predicts trends, or based on that, based on the trends or changes in the data that it has seen, it predicts how this will how these trends will
Projected in the
continue.
future.
Yeah, that's it can be used, and it is used in such tasks, and that's also the basis of model creation. So that's another
Yeah.
how should I say, facet or field in artificial intelligence. And yeah, we can also add or change different parameters and see how will that affect our the process that we'll study. We can study it in different with different parameters or different effects on it, and see what change will that lead to.
Yeah, I have last question before we go to the two questions of Aya, because she put just another question in the chat.
Yes.
One last question. If we would like to model something like this, how much time we need to do? If again, I will give you an example of Varna. If I would like to say, okay, we would like to analyze the future of the economic future of Varna based on the data that we have now.
Yes.
Tasks like this, in order to build the scenario itself, to get the data, train the model, and start to make it, how much time we need?
Oh,
It's just a question for curiosity. I know it's different from person to person, because if you are dedicate your time, you may finish it in very short time. If you don't work it in an efficient way,
you
it can take
mean
some time.
for a given person to
For a given person, yeah.
yeah
If I ask, for example, Tamer will do something like this.
again, it depends, as you said, on the experience, but also mainly depends on the algorithms are already there. So you need, and this is often one of the most serious moments, data, and you need to extract features and create models based on that data. So it is often such tasks are related to the complexity of the modeling. So if it's a very complex model, a lot of features, a lot of data is required, and a lot of processing of that data, a lot of many parameters of it and many relations will have to be searched for and explained, and this may take up some time. So again, it is strongly dependent on the complexity of the model. The more complex the task gets, it is the more time it will consume. Again, very strongly depends on the complexity that you aim for.
Okay. Yes. Good. So maybe now we can go to the two question of Aya. One question is about software. She asked about what software, what are the software of AI?
Software for AI. So, as I said, MATLAB machine learning toolbox, if you have MATLAB, is a very good place to start. Then also Python has a lot of toolboxes and ready uses, but it is very, how should I say, a problem there is that you require some programming knowledge, and but Python is also a good approach. As I said, Weka is a machine learning platform. It's entirely free, and you can use it for all kinds of different tasks. So it has you can do classification with it, regression with it, feature ranking, feature analysis. So there are a lot of, as I said, it is a good approach that can be taken. It is a simple program. It has a lot of explanations and resources in order for person to start working with it, even if he has not worked before in the field. So, and rapid miner, and as I said, the rapid miner in the next lecture in Friday, there is a presentation and examples with rapid miner. So there you can go
more detail.
yeah, indeed, there they will, the software and will be shown in detail there. So if anybody has interest,
actually, I try to correct the question. I think this is out of the context here, but maybe I can ask you, Virgan, for this. She said, what's the best software for simulation?
Oh, for simulation,
which is
now,
different than AI, I think.
Yeah, so again, depends. Usually there depends on what you are simulating, and in different fields for different tasks, there are again specific software. So,
but I think MATLAB is one of the best.
Yes,
in general.
MATLAB, if you're going to develop your application entirely on your own, or it's a very, very good starting point or tool to do that, not only starting point.
You would like to ask Aya direct?
Sorry for interruption, but I would like to ask about the geology.
Yes.
What are how can the geologists use AI in simulations, and how can get the data?
Simulation of what?
In general, in geology, such as classification of rocks, modeling, and so on.
Okay.
Yes. So about about the data. So if there are ways, for example, satellite images and there are different such commercial platforms where you can download satellite images and use them as a starting point. Another, if you have photographs of different types of rocks, or applications can be created that classify these different types of rock from images. The problem is with about the data sets, if there aren't any data sets ready and available. As I said, creating a data set is on its own a very complex task. And by complex, I mean it is very time consuming, a very effort consuming. So it might, as I said, it might require, if you're going to classify images, rocks and rock formations or rock types from images, maybe you need the rock formation that you're, or the rock type, and you need a number of images of it. As I said, it is, variety is good. It helps you create a model that is more robust, that it doesn't doesn't how should I say, hiccup at the first
First trial.
not try, but it's very good at classifying a
Yes.
given rock. But if you have it at a different angle or at a different, or if it's there are some obstructions on your way and it just it's unreliable. So
Yes.
a lot of data is required and different types of data to create the best models possible. And as I said, this is often exhaustive and long work.
Yes.
So
Maybe I can
yeah.
reflect on that,
Yes, of course.
Vargan, because we are working with Technical University of Varna on such model area. So
Yeah.
actually we have something called in our Cloud Earth I project, we have something called Access Earth. This is a project or sub-project. We are working on that. It's still immature project.
Yeah.
It's using artificial intelligence. The main idea is to use artificial intelligence to use satellite data to automatic maps the geology.
Yeah.
And what we are doing, it's actually two steps project. So the first thing that we need to download the correct satellite image. And I think Professor Angel already finished this step, Vargan. So we use data,
Yes.
the weather data. So we say, for example, the user, I will give her example from Egypt. For example, the user would like to map the geology around Cairo, for example. So the algorithm automatic goes and start to go to satellite data from Cairo, download it to all of them, and then the algorithm will go automatic to the weather condition that cover Cairo or cover Egypt from all the year, the entire year. And according to this weather condition, the algorithm start to say, okay, better way or the best satellite image should be in the summertime, for example, because in the summertime you don't have cloud. While if you go to the condition at the winter, you have cloud. So the algorithm automatic will download the satellite image that has less clouds from the satellite. Okay. Then we start to work on the next step, which will be how we can identify these rock units. And in this issue, we need data. And this is a big challenge. So when you ask about the data, how first how we will do that? Simply, we will try to train the models as Vargan showed us now today. We will bring a lot of data, mainly number, not photos, numbers. And this numbers is related to coordinate like lat and long, like pixel, because its coordination is a pixel. And we start to see this number, try to analyze the number to see, okay, if you have a high silica, this is granite. If you have a low silica, this is basalt. If you have this number, this rock is like this. So we try to use this number in order to classify the rocks and then link this classification to the pixel. So try to find pattern in the data to say if you're in satellite image, you have this color. When you are using these bands, this means this pixel is equivalent to granite or is equivalent to basalt. So we try to produce this model somehow. But this is how we are doing that. So if I came to the second question for you about the data, actually we don't have enough data.
Yeah.
So we need to collect data. So actually collecting the data is a challenge. I think this main challenge to create artificial intelligence tools also.
Yeah, this is if I can just add, this is the constant and
Yes.
everlasting problem. You
Yes.
always don't. There always isn't enough data.
Yes.
So
And
you
you can't
always
and you
need
can't move
more.
without it.
Yeah,
You need
and you
data.
always need more data. And even
Yes.
when you're done and you have your database, and suddenly turns out that maybe
You're missing
there
something.
was something else that could
Yes.
have been added, or this is also a problem that you always need more data. And
Yes.
this is I will just very briefly on that, but people often say that or suspect that there is something sinister with for example these IT corporations always gathering data.
Yes.
Yeah, they're doing that just because uh, the algorithms that they
Yep.
develop require
Data.
enormous amounts of data.
Yes. Yes.
For example, and I will just give with Siri or other voice to text software. For this software, in order for it to be universal and many people to use it, they really need a lot of data
Yes.
with a lot of pronunciations, a lot of accents, a lot of specifics, because there, even if everything is as accent as is the same, sometimes the pitch of the voice can confuse it. So they need
Yes.
maybe more high pitched voice, more lower, deeper voices. So that's one of the reasons data is always
Yep.
required and always in huge amounts.
Yes. And this is how, for example, Facebook make money, because Facebook make money from our data. He just collect the data, our data,
Yeah.
and start to use the data to train several artificial intelligence models behind it. So
Yes, and
yes.
this is same thing with YouTube. They just, they make money by keeping you there, and they keep you there, but by knowing what you would
Yes.
click next, and that's why they need
Yes. So
that data.
so for example, I can give another example to all the audience here about the powerful of data and artificial intelligence. Sometimes when you are trying to search on Google, for example, a street or a restaurant or something like this, you discover that when you are going to Facebook, that announcement on this restaurant in this area start to appear.
Yes.
Simply because it's again linked. So they collect your data, they turn it into module, and then they link this data to announcement for or advice for some companies, and then it's appear to you.
Yes. So it is
It's powerful of data. So
yeah, and
yeah.
again, to make all kinds of algorithms, generally you need a lot of data. Yeah.
Yes.
If we can, uh, summarize it like this,
Exactly.
data is king.
Yes.
Yeah.
Yes. Good. So I don't know if anyone has any
Yes, and if there are
any
other
questions?
questions, if not now, but later on,
Yeah, just
somebody
yeah.
thinks, I mean, if somebody uh, has a question, and the beginning, I have in the presentation, I have placed my email,
Mhm.
so you can send me your question to the email, and I will try to answer it as
Super.
best as I can.
I have one last question for you, which is related to the presentation. Is this presentation somewhere on the Dropbox? No.
No.
So do you think is it okay for us to have a copy of it in order to upload it on or send it to the people here?
Yes, I will go through it one more time,
Super.
prepare it. If there are some things that need fixing or
Super.
specifying,
Yeah.
and I will send it to you so you can
Great.
provide it.
You can make it like PDF, or you can send it as a PowerPoint as you like,
Yeah, so
and
I
send
can
it
do
by email, and I will upload the record plus the presentation on the website of the course,
Yes.
and send email to all the audience here with the record and the presentation.
Yes.
Super. And the second thing for our audience, now I discover that next session will be the 9th of December.
Yes.
I think it will be next Friday. I think so. And at the same time, I will have another session. So actually, we can't use the same Zoom link. So I will send you another Zoom link to be used for the coming session. Okay, so
Yeah.
please, because when you are registered, you got an automatic email to say that the Zoom link of the workshop will be like this. But actually now we can't use this now. So this will be used for another meeting, and you will get another Zoom link for our session next Friday, I think. Just to be sure. Friday, yeah, next Friday.
Yes.
Super.
Okay.
But this is not for you, Wagner. This is just comment for
Yes.
for other people. Yeah.
Yeah.
Yeah. So I would like to thank you very much for this very interesting like brainstorming discussion presentation.
Yes. So
And
hope,
yeah, I
of
think it's
course.
very useful.
Yes, I just wanted to say that I hope it has been useful and
Yes.
interesting. And if any other questions by, as I said, the participants and both the people who will watch it later on, if you have any questions, you can contact me on my email.
Yes. And to follow up, I think the coming session will be about big data next Friday.
Exactly.
So maybe will cover the question about that I asked about the big data. So actually we need data in order to train the model, in order to create this artificial intelligence tools. So the coming session next Friday will be on the big data. So
both on big data and practical approaches in machine learning and
yes,
artificial intelligence.
yes. So we will try to cover this question somehow.
Yeah.
Yes. So thanks a lot, everyone, and I wish you a nice weekend, and see you all next Friday.
Thank you. Goodbye.
Bye bye.